This video lecture addresses image classification as it relates to the fields of remote sensing and geographic information systems, GIS. We classify things because it helps us understand. Classification is the process of assigning a pixel to a class. Think categories, groups, etc. Classification will depend on what is of interest to the analyst or the user. Many different classifications are possible, and classes form regions on the image. Class membership can be identified through symbols, for example, color or pattern. In remote sensing, we say that pixels within groups or classes are spectrally more similar to one another than to pixels not within the same group or class. There is no single best classification for all images and projects, as classification depends on source data and end use. It is not possible to tell how an image was classified without a written description of the process and techniques employed. For example, was a supervised classification used where an analyst guides the classification process and identifies areas at onset that are known to belong to each class? Or was an unsupervised classification used where the analyst provides minimal input, sometimes setting the number of classes, but not guiding the classification process? In an unsupervised classification, natural pixel groupings are presented. In practice, a hybrid classification is possibly what was used, where there is some oversight in groupings and some computer assignment of groupings. In ecological statistics, this reminds me of why we run cluster analyses that 1. Start from the entire group and splits it down into groups, and 2. Starts with each individual and builds up into groups. You get different answers, and both solutions are informative. That is to say, an analyst may decide to run different classification techniques on the same data to find the technological classes that make the most ecological sense. As GIS geography describes, in supervised classification, quote, pixels are grouped based on the reflectance properties of pixels. These groupings are called clusters. The user identifies the number of clusters to generate and which bands to use. With this information, the image classification software generates clusters. There are different image clustering algorithms, such as k-means and isodata. End quote. Unsupervised classification was first applied in remote sensing and has some important advantages. For example, unsupervised classification requires no extensive prior knowledge of the region under study, and it minimizes the opportunity for human error. Another advantage is that unique classes are recognized as distinct units. Of course, there are also disadvantages and limitations of unsupervised classification. For example, the resulting classes are not necessarily correlated to the analyst's interests, so the resulting classes may not be informative given the intended application. Another disadvantage is that there is limited control by the analyst for controlling menu classes and class identities. Also, spectral classes may change over time. That is, classes may not be useful outside the application of a single fly date. As GIS geography describes, quote, the user selects representative samples for each land cover class in the digital image. These sample land cover classes are called training sites. End quote. The image classification software uses the training sites to identify the land cover classes in the entire image. Quote, the classification of land cover is based on the spectral signature defined in the training set. The digital image classification software determines each class on what it resembles most in the training set. The common supervised classification algorithms are maximum likelihood and minimum distance classification. End quote. Advantages of supervised classification include that the analyst controls the categories, which are tied to specific areas of known identity. So, in other words, the spectral categories are distinctly tied to area of interest. This analyst knowledge may help identify errors in classification. Several disadvantages and limitations are also apparent in supervised classification, to include that the structure imposed in the classification is shaped by the analyst's preconceived ideas. As well, training data are based on informational categories, not specific spectral categories. Training data may not be representative over the range encountered within the entire image. Training data selection can be time-consuming, expensive, and tedious, and some unique classes not in training sets will be missed in the classification process. With higher resolution imagery and the integration of multi-resolution imagery, object-based image classification has emerged. As described by GIS Geography, quote, traditional pixel-based processing generates square classified pixels. Object-based image classification is very different in that it generates objects of different shapes and scales. This process is called multi-resolution segmentation. Multi-resolution segmentation produces homogeneous image objects by grouping pixels. Objects are generated with different scales and in an image simultaneously. These objects are more meaningful than the traditional pixel-based segmentation because they can be classified based on texture, context, and geometry. Object-based image analysis supports the use of multiple bands for multi-resolution segmentation and classification. For example, infrared, elevation, or existing shapefiles can simultaneously be used to classify image objects. Multiple layers can have context with each other. This context comes in the form of neighborhood relationships, proximity and distance between layers. Nearest neighbor, NN, classification is similar to supervised classification. After multi-resolution segmentation, the user identifies sample sites for each land cover class. The statistics to classify image objects are defined. The object-based image analysis software then classifies objects based on their resemblance to the training sites and the statistics defined. End quote. The following sources were consulted in developing this video lecture.